Hello student, today we will discuss about cooling tower calculations. So in previous video we have studied about what is cooling tower and how it works. So basically cooling tower used in a process chemical industry to cool the processed liquid or fluids. So basically in a cooling tower we have, in today's lecture we will calculate how we calculate the total requirement of makeup water. So makeup water is equal to evaporation loss, drift loss plus blowdown loss. So individually how we can calculate it, now we will see. So it is a schematic diagram of induced type of cooling, cooling tower. So basically you can categorize cooling tower on the basis of drop in two types. First is natural draft, second is mechanical draft. In natural draft, the air flows or drop without any mechanical device. But in a mechanical draft, we use fan for drafting of air. Okay, so it is an induced type cooling tower, because induced draft type cooling tower, because in this cooling tower, fan is mounted on the top, and another is also a forced draft cooling tower, in which we mounted this fan here at mid or bottom section of cooling tower. So here it is mounted on top, so it is an induced drop. So air flows between these packings through which liquid droplet is moving downwards. So this air will come in contact with water. So water vapor will get evaporate and will go in atmosphere. Okay. Suppose here the temperature of cooling water, which is we are processing in process plant, is TC. It is TC, cold water. After the process plant, the water will get hot. So hot water will go in a cooling tower. This is the header in which this hot water comes, and through nozzle it will spray on whole cooling tower. Okay. So now come on the evaporation loss. How we will calculate evaporation loss? So basically we know that what is the heat load? Heat load nothing is mCp delta T. What is m dash? It is hot water, m dash. Circulation, you can say circulation rate through which pump is pump is transferring this fluid to cooling tower. It is a circulation rate, m dot. It also can be expressed in terms of meter cube per hour. Then you can calculate and you can convert meters to kg. So you can say here m dot is kg per hour. You can convert water meter cube per hour to kg per hour. Cp, what is it? Is a Cp of water, a specific heat capacity of water. What is Cp? Cp is nothing, specific heat capacity of water. What is this value? Its value is 1 kilocalorie per kg per degree Celsius. 1 kilocalorie per kg degree Celsius. In terms of joule, 4.18 kilojoule per kg degree Celsius. Okay. What is delta T? Delta T is the difference of temperature. It is a temperature difference between cold water Tc and this Th minus Tc. Divide by Hv. What is Hv? It is the heat of vaporization. Generally, heat of vaporization is 540 kilocalorie per kg. Okay, it is a heat of vaporization of water. How much heat is required to convert water to vapor? It is a heat of vaporization. This is nothing is 540 kilocalorie per kg. Okay. So with this formula you can calculate evaporation loss. So drift loss, generally drift loss in the calculation we take it as a negligible because the value is very less. So for the induced draft type cooling tower, it is 0.1 or to 0.2% of circulating rate of hot water or water which is flowing in, which is coming in and which is flowing in the pipeline or which is coming in the cooling tower. It is the value comes between 0.3% to 1% in natural drop type cooling tower. And when you use drift eliminator, then its value is 0.0005% to 0.001, 0.001, 0.001%. So in the calculation we take it as a negligible. So how we calculate flow down? It is nothing, evaporation loss minus COC minus 1 into drift loss divided by COC minus 1. If drift loss 0, so it becomes evaporation loss divided by COC minus 1. So what is COC? It is nothing but cycle of concentration. It is a cycle of concentration. What is COC? It is a cycle of concentration. So how you will calculate COC? It is a nothing, hardness of cooling water divided by hardness of makeup water. Okay. Suppose your cooling water hardness is 1500 ppm and your makeup is 150 ppm. It is just example. So your value will come 10. COC is 10. But generally in a process industry, the COC value lies between 3 to 7. The COC value lies between 3 to 7 in chemical process industry and in power plant also. Okay. COC is nothing, it is a cycle of concentration. It is cycle of concentration. It is a hardness, or you can in terms of solid of cooling water, or divide by solid of makeup water which you are just fed in a sum or basin of cooling tower. Sum or basin. Basin. It is nothing but it is a sum in which cold water will collected. Okay. So in this video we have learned about how we calculate evaporation loss, drift loss, blowdown loss, and what the purpose of these losses. By calculating these losses, you can calculate how much quantity you require for makeup water in your cooling tower. Okay. So what is the need of makeup water? Why we need? Generally, interviewer can ask the question, why we need makeup water? So simple answer is that if you will not make up the water, so the quantity of water will reduce. The quantity of water will reduce with the time because there is a evaporation loss, some drift loss. And the second reason is, if you will not make up the water, so what happen? What will happen? So the concentration of solid hardness will increase of the cooling water, and it will go in your process plant, basically in a heat exchanger. So it will get deposited in the tubes of heat exchanger, and your heat transfer will be not proper. You will not get a good efficiency. Okay. So this is the reason of why we make up the water in a cooling tower. Okay. Hope this is clear, all of you.